All right, guys, let's take a look. I know you're not quite done, but the last few are spheres, and those are pretty straightforward. So we'll work through these. What is the name of this guy here?
I got hexagonal sphere.
Hexagonal
Prism.
prism. Yeah.
We're right.
You can call him Horatio if you want to, but his official title is hexagonal prism. And then, of course, how many lateral faces does it have?
I wouldn't have that.
Holy shit, because it's got a rectangle coming off each edge of the hexagon, yes? So it's got 6. And of course, each lateral face is a rectangle, like we just said. And then, can you give me, now, a lateral edge? It should kind of make sense that a lateral edge is an edge between two lateral sides. So like VT would not necessarily be a lateral edge because it's between a lateral and the top. So give me a lateral edge. TE. And then you just keep going. All these guys, all these parallel things are going to be, so VF would be one, blah, 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 blah. Okay, that first one, not too bad. Want to start you off nice, throw you off the track for later. How did these go? Each of these have something in common.
What type of prism?
Yeah, every one of these is a prism. So if you kind of like fold over every side and then just cap the top and bottom. So in general, a prism that's constructed from polygonal bases, yes, are going to have what kind of shapes connecting the top and the bottom base? So like up here, what connected the top with the bottom is a rectangle, yes? In fact, if I just add more sides to the shapes that I use for the bases, I'm just going to have smaller and more rectangles, yes? So it kind of makes sense. These are rectangles, and so I'm going to end up with a prism. So this one would be what kind of prism? Yeah, pentagonal. Excuse me. Prism. What about this guy? Cylinder. You could also call it a circular prism, but this book doesn't like that. And then this one, of course, would be, yeah, you could call it triangular prism. I like it. Okay, not too shabby. Now these two, well, all of them, every shape we talk about, it has a kind of complicated looking formula. Formulas always look more complicated than they have to for any given specific situation. So if you could just find the area of every face, just add them up. So remember what I said about surface area is like the 3D analog to perimeter? And do we have to know any perimeter formulas? No. Now the difference here is everything I'm going to add is an area. So I do have to know area formulas. But if I can just get the area of all the faces, I'm just going to add them all up. So here, if you wanted to, this is a prism, yes? Why is it a prism? Yeah, it's a repeated shape. It's a repeated rectangle. So I could look at it as this shape repeating up this way, this shape repeating over that way, or this shape repeating over that way. Yes? So so one way you could do this problem is to take your, there it is, this formula here. I'll catch up with the rest of you. I know some of you guys are like, I didn't do it that way. Great. So if I look at this as my base, this guy, the repeated shape, the top and the bottom, it would be twice the area, Jeff. Put your glasses. So this would be twice 99, it looks like. Plus the perimeter, and the perimeter of this would be 40, yes? Times the height, which would be 10. Now real quick, I told some of the groups, for a prism, what really, really sucks, especially when you have a triangle, the idea of H is trippy. So when you get here, H is just how far is the shape repeated. So this is a triangle repeated this way, yes? And it repeats for 6 feet's worth. So that would be the height of this prism. Okay, I like it, maybe. It kind of sucks when we have two freaking separate heights that we have to worry about. Okay. What's this? 598? Is that right? Is that right? Yeah. Okay. 598 watts. Now, did somebody do it a different way? Nobody? Everybody did it this way? How'd you do it?
I just found the areas of all the faces.
Yeah, so you got 99 and you doubled it, and you got 9 times 10 and you doubled it, you got 11 times 10, you doubled it. Yeah. So again, if I ask you for surface area and every face is an easy shape, just find all the areas of the faces and add them up. Kick ass. So this is the same thing. So let's do it the other way. So if we got 18 square meters twice, right, for the bottom and the top, and then I've got 14 square meters for these two sides twice. Good Lord, Jeff. Plus the 63 square meters twice. What the shit's that going to be? Wait a minute, 32, 95. 190? Yes? Okay. Or you could do the formula. Up to you. 22 is the first one you guys hit that I think really kind of tripped you up a little bit, but I need the height of the triangle to get its area. If I draw the height in, I create a little right triangle here. How long is this side? 7. And so I need to know this. This is also 7. So then I just have to use old Greek dude to help me out a little bit, right? Wait a minute. This can't be 7. 14. Thank you. Yeah, I know. I immediately I was like, well, that's going to be 0. That sucks. So how do I find the height? This height here. I'm going to call it capital H just because. Yeah, good old Pythagorean theorem. It'll be 14 squared equals 7 squared plus h squared. So h will be 120? No. 1 up, Jeff. 196 minus 49. 147. Okay, thank you. That's h squared, yes?
Yeah.
So h is the square root of that. All right. So then I can get the area of my triangle. Area of my triangle here is going to be 1/2 the base times the height. But you all agree I'm going to have 2 of those, yes? Is that all right? Keep doing this like you're holding me up. Okay, so that's that. And then I want to add in I could either add in just the areas of the rectangles that are connecting them, or I could do the perimeter of I'm just going to do that just because I sort of am doing that. The perimeter of this would be 42 times 6. So if I add those up, I'm not going to do that in my head, thankfully. Well, let's see. Easy 8 plus 252 is 168. 252 is yeah, Jeff. 520? No, 420.
Yeah.
Yes, roughly.
Yeah, 421.
Yeah, 421. 420. 421 point something.
Yeah, you got it. 74.
74. Okay. And then what would the units be?
Feet squared.
Square feet. I like it. So real quick, that problem you could have gotten the height for the triangle, got the areas of the triangle, and just got the areas of each rectangle and added them up. Some of you guys did that. Or you can just plug it into the formula like I did. Okay. These three are the same thing. This one's a little trippy because I had to give you the hexagonal area formula. These two are basically the same thing, except this guy is trippy when you first look at him, possibly. So this one, I do the same thing. I get the height, and I'm going to multiply by, I'm going to get the area of the triangle, so forth. So number 23 is exactly the same as number 22. Yes? Just with different numbers. Is that cool? So the height would be the square root of 32. Maybe? Yes? Okay, thank you. So the height of the triangle is the square root of 32. So twice the area of the triangle would be 4 times the square root of 32. I love you guys. And just to do this one a different way, I could add in the area of this rectangle, which would be 6 times 7.2. And I've got 2 of those. And then I've got the base, which would be 4 times 7.2. Oh my God. So that would be 86 point, I've lost it. Plus like 20, so like 106 or something around there. I don't know. Did I lose the thread? So me, if I do it this way, I get so real quick, I'm sorry, let me stop for a second. Did anybody do it the way that I'm doing it? I'm doing it this way because I want to do it a different way for this one, because it's basically the same problem as the one before. Got the areas of the triangles, and I'm just going to add in the areas of the rectangles. Yes? Maybe? So I get probably did something wrong as I try to do it in my head. Oh, 137. How's that?
Yeah. There we go.
Okay. Somewhere in my head I lost about 30, but that's okay. How are you guys doing? Did you get something different? What's up? Sorry. How are you guys doing? Everybody all right? Yes? Oh. What'd you get? Oh.
I don't know what I did.
I don't know either. I'm not sure. Oh, you probably square rooted 32 and then rounded it?
Yeah.
So if you round too early, it's going to throw your answer off at the end. But I'm obviously going to give a little bit of leeway. So when I put it in, I just put the square root of 32 in so I didn't have to round it. I just let the calculator worry about it because this guy costs enough money. I want him to stress out over shit. Okay. 24 is the exact same thing again. Except 24 is a little bit nicer. Can anyone, now on one side it's weird because they kind of laid it down weird, but can anyone tell me what's one thing in 24 that I don't have to do that I had to do in 23? Find the height. I know the height of the triangle, which I'm calling big ass H just because. We know the height of the triangle is going to be 6.4. Is that cool? Because that's going to be this edge here. So then the area of the triangle is going to be 2 times 6.4 cut in half, but I have 2 of them. So it's 2 times 6.4, which is 12.8. So that's the area of the 2 bases, the 2 triangles. And then again, I could do it a few different ways. So let's do it the other way now. So I could do the perimeter of the base, which will be 2 plus 2.9 plus 2 plus 2. So that'll be 4.9. That'll be 9.8, I think. Times, where am I at? Times 6.4.
Would you divide by 2?
Huh?
Would you then divide it? Because that shape doesn't repeat through the whole thing.
Oh, yeah, that's right. Okay, Jeff. I need the perimeter of the, this one tripped me up too because it's laying on its side. The perimeter of the triangle is going to be 2 plus 2.9 plus this.
Plus 6.4.
6 point, no. Oh.
2 plus 6.4.
All right. 2 plus 6.4 plus this.
Yes.
And what is this here?
6.7.
Yes. So how did you get this side? Right there. So it'll be 2 plus 6.4. Oops. Plus 6.7. That's the perimeter of the repeated shape times how far it's repeated, which is 2.9. Wow. So that'll be 12.8 plus all that business. times 2.9. I get, there we go. 56.59. Doop. Yeah. No? Yes?
Yeah.
Okay. And again, I did this one with the formula. You could have just found the areas of each rectangle, yes, and added those together. Either way, okay. This one, let's get this hexagonal area thing figured out first. So one of these guys is going to be rad 3. What was it? 3 rad 3 over 2 times a squared. So that comes out to be 6 rad 3, I think. That's the area of one of the. Oops, sorry guys. That's the area of one of the hexagons. So if I double that, because I have another hexagon on the other side, I'll get 12 rad 3. And then I just have how many of the same rectangles? 6. So if I just do plus 6 of these rectangles that are 2 by 6.1. Okay, so I keep kind of bouncing between the formulas and just getting the areas of all the sides, but it's up to you. You can do it either way, that's easier. And if you do that, you get 93.98. What would the units be? Good. Kick ass. Is that what you guys got?
Yeah.
Yes? Yeah. Okay, good. Good reaction. All right, real quick. Cylinders, you gotta love cylinders. Cylinders kick ass. So if I just do the last one here, what's the thing you gotta be careful about with this cylinder? What do you need? Radius. So what's the radius? 3.1. And then you've got, I've got 2 circles plus 2 pi RH. 2 pi RH is me unwrapping the sides of this sucker, right? 2 pi R is the length and then H is the height, so it just is a rectangle. So then I just have to plug all this business in. 3.1 squared plus 2 pi 3.1 times 10. Shah. So we get 2 times pi times. Oh, no, Jeff. There you go. Plus 2 times pi times 31. I get 255. So what do you guys got? Yes? Okay. And the crowd goes, eh. Okay. The other two work the exact same way. Yes? Okay. All right. And then I decided to try to be a little nice. These guys, what I'm missing is the actual height of this triangle, for example. But if I just draw the height over here, I made a little right triangle there. So this is how I could always figure out the lateral, what this book calls it, is height, lateral height of the pyramid by chopping out a little right triangle in the middle. If I redraw that little right triangle, how long is this side? 4, good. And how long is this? 12. So then I can figure out what this is. This would be the square root of, I'm sorry, yeah. Square root of 144 plus 16, so square root of 160. So then the area of this triangle here, is going to be 1/2 the base times the height, which will be roughly 52, so like 50 something. Let's see. How close is Jeff? Yeah, I get 50.6. Yes? Square meters. I love it. This works the exact same way. Yes. This would be 11 here. So then I could just do 22 squared plus 11 squared. Take the square root, get the height, plug it in. Okay. The difference between these two down here is this one gives you the actual slant height. So if I want to use the formula directly, this guy, I've got this. So the area of the base plus half the perimeter of the base times the slant length. So this would be, this is a regular pyramid. So the bottom is a square. So the area of the base plus the 1/2, the perimeter of the base, and the perimeter of the base would be 44.8 times the slant length, 17. So that was kind of nice because it gave us exactly all the parts I needed just to throw it directly into the formula, no issues. If you wanted to, you could instead figure out the area of that triangle, this guy here, multiply him by 4, and then add in the area of the square. It's the same thing. So here you get I get 506.24. Did you guys get that? Okay, even if you did it a different way, you should get that. I like it. So this one, I've got to first find this, which is why they gave us this problem up here. So I'm kind of ready for it. So how long is this side here? 4. So then I could do 169 minus 16, right? I could do a squared plus 4 squared equals 13 squared. 169 minus 16 is 153. So I get the height of this to be the square root of 153. Yes. And then that's the, let me give it the right letter. That is the L. So again, you could find the area of this, multiply by 3, add in the area of the bottom. What kind of shape is the bottom? Be specific. Equilateral triangle, I like it. So you get the area of the base. It, of course, is its own problem, because why not? So if I kind of draw equilateral triangle here, draw in the height, I can get its height would be square root of 48. 32, am I in my head right? No. Yes. Yes. All right, so I'm going to get the area of the base, which is a triangle, an equilateral triangle. And then I could get the area of each side, or I could just plug it into the formula, either way, yes? So the base is going to be 1/2 the triangle's base times its height. And then I want to add in 3 of these triangles if I want to do it this way. There it is. Whew! That is one way to do it. You don't have to do it this way. Oh my God. So I get 176.14 square centimeters. Did anybody get that one figured out? Man, you guys are so done. Okay. I don't blame you. I don't blame you, really. So very quickly, this is exactly the same idea, yes? I just have to find that hypotenuse for that. Is that cool? All right, so I'm going to kind of bypass that. You just have to do good old Pythagorean theorem. The area, the surface area of a cone, if I know the slant height, I just have to plug it into this. So in this one, I know the slant height. Good, I remember that. So this would be pi r squared plus pi r L. So this will be pi times. I get 436.18. And then number 25 is set up to use the other form of the formula, this guy, because I know the height and the radius. So then if I use that guy, I just have to plug and chug. Right, so it'll be pi times 4.5 squared plus pi times 4.5 times the square root of the height of the triangle. I'm sorry, yes, sure, of the triangle, of the cone. Squared plus the radius of this squared. And then just plug it all in the calculator. Okay. Pushing my luck today. Let's see. So that's just plug it in the calculator. Is that okay? Okay. And then these last ones should hopefully be pretty nice because the formula is really straightforward. What's the formula for the surface area of a ball? Yeah, 4 times the area of the great circle. I like it. So then this is beautiful. This is the best problem in the whole dang thing. I just have to put the right number in here. So over here, what number should go in? 3.85, I love it. Kick ass. And then it's just plugging in the old calculator. Okay. All right. Today was one of those days. Just a lot of numbers, a lot of pushing buttons. So the plan, of course, Monday we're going to have the quiz first thing, 12.6, 13.1, 13.2. We're going to get into section 13.4. I'm going to do the same thing next week, lecture 13.4 on Monday, and then Wednesday we'll have another one that's at least as fun as it was, worksheet. Maybe I'll have some stuff you can do, you know, tactile, kind of break things up on next Wednesday. All right, guys. Have a good weekend. We'll get some ibuprofen or something.
Please stay sunny.
That would be nice. I think it's,